So hello everyone. Today we will solve the maximum subarray problem of the lead code. So let me share my screen. Um, so this is the problem of the today that we are going to solve the maximum subarray. You are given an array. You have given an array this in which the negative and the positive number, both numbers will be there, and you have to find the subarray whose sum is maximum, means the largest sum, and you have to return that sum. Suppose that here, if you take 2, right? So it is sum is minus 2. Sum is minus 2. Then you come to 1, right? So it will be, we will update the sum that minus 2 and 1 will be minus 1. Then we will come to here, minus 3. It will be minus 4. Then we'll come here, 4. It will be 0. So my intention is telling that you have to find a subarray whose sum is maximum. So we can see here that let me clear my screen. So we can see here that it is a subarray whose sum is maximum. You can see over here that if you add 4 minus 1, 2 and 1, the result will be 6. Right? 4 plus 2 is 6 and minus 1 is 0. So the largest sum is over here is 6. So if there is only one element in the array, you can return that element. So there, I'm going to tell here four approaches to solve this problem. The first one is the naive approach, which can be solved in the time complexity of big O of n cube. Uh, the next one is I'm going to optimize that, which is n square. And the third one is that we'll use Kadane algorithm, and due to which we achieve big O of n. And the fourth one is we can use divide and conquer, which will take n log n. And we can also solve it using DP, which will give a time complexity of big O of n. Yeah, so we can uh, take this problem in the in the five different ways. So I hope that you will understand that when we start from n cube till here. So let's start the solution for the n cube. So n cube, what will be that? I will write code and simultaneously I will explain, so it will be take less time to understand, right? Uh, see, the thing is that in n cube, what we are going to do, we are taking a loop, outer loop, which will be I'll write the pseudocode for. We'll take a outer loop which will be from 0 to n minus 1, and this will be the outer loop, and the inner loop of this is from j. It will suppose that we are taking this is the subarray, and then this is the subarray, and then this is the subarray, and then this is the subarray. Like this, we are going to calculate the sum of all the subarrays, and whose sum will be maximum. We will store that in the max variable. So the jth is from I to n minus 1, and one we have to take a loop which will iterate from I to j. So k is from I to k is equal to j, and we will sum that sum plus equal to array of k, and we will update this max to this sum, right? So this how we get order of n cube. So let me write a code for this. Uh, so, so first we'll takes the length of this array, nums dot length, and then what we'll do, we will run a loop that int I equal to 0, I less than n, I plus plus, and then for int j equal to 0, j less than n, and then j plus plus, and then we will run a loop from k equal to um, I till k less than j, till k less than equal to j and k plus plus, and then suppose I have to start from I, right? J equal to I, j less than n, right? And we have to find the maximum, right? And for finding the maximum, we will take sorry, we'll take one max variable, which will be in Java. It is integer dot min underscore value, right? And we have to find the sum, right? And we have to find the sum. We have to find the sum for every, right? So here we will take int sum equal to 0, and though we'll calculate the sum, right? Sum equal to sum plus k, nums of k, and here also we'll find the max value. So max equal to math dot max, and over there max comma sum, max comma sum. So yes, so we'll find the maximum value and then we'll return this maximum. We'll return this maximum. So let's see that if it codes runs or not. Mm, yeah, here it is accepted, but it will give TLE because it is n cube, right? So let's see how many test cases are passed in this. Um, See over here. Uh, Out of 200 cases are passed, right? Only 10 cases are remaining, which are not allowing this big O of n cube solution, right? So we will move to the big O of n square solution. Means that we will remove the need of this k kth loop. How we will remove the need of this kth loop? We will remove the need of this kth loop means suppose we are using this kth loop because suppose I is over here and j is over here. So till here to here we have to calculate a sum, right? So this for this we are using this loop over here. But if we don't using this loop, if we don't use this loop and we just side along with this when j is traveling along with that only we calculate the sum, then we will not need this loop, right? So I hope you understand, and I will write the code for this. Once you see the code you will understand. Do a dry run for this, uh, then only you will be able to understand it. uh, I will take the sum of this, and when j equal to I, j less than n, and uh, yeah, I think it will work. Okay, so here will be j. Okay, let's submit it. Okay, so you can see that over here, four test cases are more passed. Before it was 200 and now it is 204. And so this was the big O of n square. And now if we want to solve it in big O of n, right, using Cardano algorithm, then we'll use a Cardano algorithm which says that uh, you have to take a prefix. You have to take a prefix, and when that prefix, you are going to take a prefix. I will tell you. I will tell the Cardano algorithm also. Let me explain it. We will take a sum. One sum we will take, and one prefix we will take. So both are zero, right? And both are zero. And suppose the if prefix if we add this, right, we add this, if prefix equal to prefix dot array of 0, right, array of I, so in prefix it will be -2, right? And then in some or we will take this maximum which will be updated by -2 over here because Which will be maximum? Integer dot min value or minus 2? Minus 2 will be maximum. So max will be updated by minus 2. And the next condition we will check over here, that if this previous is less than 0, then we will update this previous to 0. This is the case over here. If the previous is less than 0, if the previous is less than 0, we will update this previous to 0, because the reason is that, okay, wait 1 second. Okay, okay. The reason is that, uh, suppose the previous is over here, and your maximum is over here, you are over here. So if you add both these two, the result will be minus 1. So it is less than 0, right? So again, the previous will be minus 1. So we will again find the maximum of minus 2 and minus 1. So again, it will update it as minus 1 max. And if it is less than 0, we will update it as 0 again. So when the previous is calculated with this, it will be minus 3. So if the max will not be updated, then because minus 1 is maximum, this maximum, then minus 3. And the previous will again update it to 0. The next will be previous will be 4, right? Previous will be 4. And the max will be updated to 4 then. There's max will be updated to 4. The next will be previous will be 3. The max will not be updated because 4 and 3, 4 is maximum. The previous will be 2, right? So it will be 5. Then max will be updated to 5, right? Uh, then previous will be 6. Then max will be updated to 6. The previous will be 1. The max will not be updated because it is this. The previous will be taking 4. The previous will be 5. The max will not be updated and the maximum will return. So this is how the Cardano algorithm works. Let me write the code for this. Um, go. So end prefix equal to 0, and prefix equal to prefix plus nums of I. Prefix equal to prefix plus nums of I. We are adding the prefix and then we are calculating the max. Math.max. But in max.math, we will write prefix comma max, and then what we'll do, we'll check that if prefix is less than 0, right? We will update that prefix. We will update that prefix to 0, and we'll return match. So let's try this. So here it will be math.max and will be capital. Mm, it runs. It runs. Okay. Uh, it works because it takes big of and time complexity. Um, this was a Cardano algorithm. Now uh, we can solve it using uh, a divide and conquer also. So let's try it uh, for the divide and conquer. So for divide and conquer, we will do recursively. So let's take function one. In function one, we'll pass this array. We will pass the left pointer. We will pass the right pointer. Yeah. Um, yes. And this is what we are going to return it. Right. So let's copy this and make a function of it, public int, and this will be returned over here. This nums will be like this. This will be left. This will be right. So we'll check a base condition that if left is equal to right. If left is equal to right, we will return nums of left, right. If left is equal to right, we will return nums of left, right. And uh, we will find the mid value. What formula will use to find the mid value? Mid is equal to left plus uh, right minus left divide by 2. We use this formula to find the mid, and then what we'll do, we'll find the left sum and the right sum. Um, so int left sum equal to mm, we'll call this function nums, and over the left we will write what we'll write, we'll write left, and we'll write over here mid. uh, for the left sum, and for the right sum, we will, what we'll do, we'll right sum equal to uh, here we'll do mid plus 1, and over here we'll do right. uh, yeah, and for the mid cross mid sum, so what mid sum will do, we'll call of another function, because over that we have to find the both the left sum and the right sum. So we'll find call another function which will take the mid value also. So here nums it will take uh, it will take left, comma, it will take uh, one second. Yeah, it will take left, it will take mid, it will take right, and then what we are going to return it. So this function too, what we will do, we have to create this function. So we are going to create again this function over here. Integer value will be the return type, and over here we have to define all the parameters. It is an array, it is left, uh, it is right, and it is mid, and it is right. So here we are going to calculate the left sum and the right sum, right? So int left sum, one second, int left sum is equal to uh, integer dot min value, and int right sum, integer dot underscore min value, and we are taking a sum that will be 0, and then we are doing a loop that I equal to 0, I less than uh, or we can say that I equal to mid, or I greater than equal to I greater than equal to 0, I minus minus, and we'll calculate the sum of this nums of I. Hmm, Sorry, one second. Um, yeah. So let's say this that we are going to calculate the sum over here. Uh, yes. So we calculate the sum, and then what we'll do, we'll uh, we'll take the left sum as max dot max uh, left sum, comma uh, sum. Okay. So we'll have calculated the left sum of it. In the similar manner, I have to calculate the sum for the right one. So I'll copy this, paste this over here, and right now we'll start from mid plus 1, because for the right side, and if it is, we'll have to be less than equal to uh, right. So less than equal to right, and it will be I plus plus. And for that we have to again do the sum equal to 0. Then it will be sum is equal to sum plus nums of I, and this will be math dot max, and uh, we'll do over here a right sum, right? This one. Right sum. And if we calculate both the sum, we'll return the left sum plus right sum. We'll return the left sum plus right sum over here, right? Uh, yes. So now what we'll do, we'll come over here. We have calculated this, and after calculating this, we will return the maximum, right? So we'll return math dot max of this cross mid sum, and again we'll use math dot max, and over here we will use left sum, comma right sum. Okay. Yes. So I think it will work. Okay, some error is going. Function one. It is the function one. Okay. So here will be minus one. Okay, all the test cases are accepted, and they have submitted the. Let's see if it is accepted or not. Yeah, it is giving TLE. Why it is giving TLE? Um, hmm, the first function, we are returning the numbers of left rows, right? We are calculating the left sum. We are calculating the right max. Should we give the correct answer? Why it is not giving? Mm, okay, so it would be less than greater than or equal to left. This was the error. Yes, so it works. So this was all the code you can see over there. And if you want to use DP over here, right, which also gives log of n, uh, then what we can do, we'll remove this, and we'll take a variable that uh, max so far, right? So and we'll take max so far as the first variable of the array, nums of 0, and max ending here, right? Max so far and max ending here. We'll take max ending here. Uh, we can take another variable name also because I'm taking this because it is relevant, right? So we'll run a loop from the first index till the and and we'll calculate over here the max ending. What max ending? How we'll calculate over here? Uh, Max ending equal to math.max uh, math.max uh, the element of the array nums of I, comma uh, max ending again, and plus the nums of I. I will explain this code. Wait 1 second. And then for the max of r, we will write max of r is equal to uh, math.max max of r comma max ending here. Uh, yeah, that's it. And then we will return this uh, max so far, sorry, return this max so far and see this if it runs or not. Yes, it runs. So by the help of this, what we are going to do over here, we are taking max so far and max ending over here at the first element, right? And then what we are going to do, we are moving from this one, and we are going to do that max ending here, that up to here, what is the max, right? If it is -2 or if it is -2 plus 1. So that decides over here, that max ending here. And what will be the max ending here till the end of the array will be max so far, and we'll return that max so far. So that's all the 5 approaches to solve this problem. Thank you.